Okay, we're doing some notes here. Notes are exciting. Okay, so if you got a segment goes from the center to the circle, that's called a radius. If you have a segment going through the center, that's called a diameter. If you have a segment that misses the center, that's called a chord. Technically, a diameter is a chord that goes through the middle. If you have a segment that goes through the circle, or a line actually, it could be a segment, but it extends beyond the edges, that's called a secant. And then the other one that we've learned is a tangent. So if you have it could be a line, it could be a segment, but it's touching at one point, that's called a tangent. Which I know you've seen this word before with right triangles. It's because it's an English word and it is used in a variety of ways. A secant and a chord is similar. The secant extends outside the chord. The endpoints are on the circle. Okay. You can have some different interactions with these. So if you have a circle, if you have two chords intersecting, they could intersect inside the circle. You have these two lines. In this case, it's a secant and a tangent intersects on the circle. And then you could have it actually outside of the circle, like two secants. The one they don't have here is a secant and a tangent. That's outside the circle. But you could have the angle, making angles on the circle, in the circle, or outside the circle are the three situations you're going to find. If you have two secants or chords, but the key is that they intersect inside of the circle, okay, here's how this is going to work. The angle on the inside, okay, and it could be this one or the one opposite to it, right? The one that's not labeled here. This angle, like angle 1, is going to be equal to the two arcs that go with it. You know what? I should use green so it matches. Let me use green. This arc and this arc, right? These two arcs are the two arcs that are important for this angle, okay? So angle 1 is going to equal, we're going to take this arc here, the measurement of arc AD, and we're going to add the measurement of arc BC, and we're going to add those together, and you either divide by 2 or you could think multiply by 1/2. Add them together, divide by 2. Add them together, times 1/2, same thing. This angle, angle 2, it's going to be equal to, or related to this arc and this arc. Okay? So for that one, you're going to say, okay, so for angle 2 is going to be arc AB and measure of arc DC. And add those together, times 1/2. That's how you're going to do those. Now we're going to do some examples. Okay? So angle AED is this one. Well, we just did this. Angle AED is going to be equal to, I'll make it X, is going to be equal to this arc plus 109 times 1/2. Okay? 45 plus 109 is 154. Multiply that by 1/2, and you get 77 degrees, and that's your answer. Okay. Next one here. STR, that's this angle right here. Okay, so it's going to be equal to 112 plus 186 times 1/2. 112 plus 186, multiply it by 1/2. 112 plus 186 is 298. 1/2 times 298 is 149 degrees, and that is this angle that it's asking for. Okay. This one here, YWX. Notice YWX is actually asking about this one, but we're still going to find this one first, okay? All right, so X 43 plus 81 times 1/2. 43 plus 81 is 124. And so 1/2 times 124 is 62. Okay, so that angle right there is 62. Well, since this is a straight line, I just do 180 minus the one I have to find this other one. So 180 minus 162 is 118. So measure angle YWX equals 118. Okay. Next one here is what's to find arc LK. LK is this arc right here. Okay. So I'm going to put an X where that's at. Now let's think about what we had. We know that the angle equals, okay, so the angle equals 1/2 and the arcs added together, right? The angle is 62. So this time what we're looking for isn't over here. We know the angle. It's saying what is this going to be? So 62 goes, and then these two arcs added together, X plus 74. Okay. So now, if I was doing this, I would multiply both sides by 2. When I have a 1/2 in front of a parenthesis, the easiest thing to do is multiply both sides times 2. Times 2 times 2, both sides. 62 times 2 is 124. 2 times 1/2 is just 1, so I end up with X plus 74. So just get in your mind, to get rid of that 1/2, just multiply it by 2. It's going to get rid of the 1/2. That won't change. This times 2 is that. Okay. Then all we have to do is subtract the 74, and X equals 50. And that's arc LK. CDE. CDE is what we're trying to find. I'm going to put an XCDE is this arc right here. Okay, so that arc plus the other arc, those two arcs, plus 73 times 1/2 equals the angle in the middle. Okay, do you remember what we did just over here? Multiply by 2. 128 times 2, 256. Subtract 73 from both sides, and we get 183. Okay. Next one here, once QT, this one. QT will make it X plus 9 times 1/2 equals, now notice the angles, this angle's in the wrong spot. I need one of these angles, right? So to find, I just do 180 minus 79, I get 101. That's the angle I'm going to use. Multiply both sides by 2. Subtract 95 from both sides. And I get 202 minus 95, 107. That's page 18. 2 more pages left for these notes. Page 19 here, angle 1. Angle 1 is going to be equal to half of the arc that's inside. So angle 1 is right here, right? Angle 1. The arc that's inside of it is AB. Angle 2, it's on this side. The arc that's inside of it is this big arc going around this way. I can't call it AB because AB would imply this, and I have to call it ACD or ACB, right? Okay. But the point, the angle is half of whatever arc is inside of it, right? It's intercepted arc is what we were calling those earlier. All right, so let's see what we got here. So this arc all around is 308. Half of 308. Let's see what that is. I'm on the wrong set of notes here. Half of 308 is 154. So this angle right here, 154. That's DEG, 154. Not really any work to show for that. This arc is 192. Half of 192 is, let's see, what is half of 192? I need my calculator. What is that, 96? That sounds right. 96. The question says, what's DBC? 180 minus 96 is 84. So DBC, 84. I also could have done 360 minus 192 and gotten 168. And I could have said, well, this arc on this side is 168 and divide that by 2. That would have given me the 84 as well. 9. Let's see here, 151. Well, the angle this time is 151, so the arc x, z, y all the way around here will be double that, right? 302. 360 is a whole circle, so 360 minus 302 was 58. So this little arc xy would be 58. K and M, the big arc here. I'm going to work this backwards. 180 minus 123 is 157, so the angle is 157. 157 times 2 would be that arc. 157 times 2 is 314. All right, now we get to the ones where the angle's on the outside, okay? Notice that angle has 2 arcs that intercept. So this angle right here, it's intercepting this arc, and it's intercepting this arc. Okay? Notice all of them, here this angle on the outside, it's intercepting this arc, and it's intercepting this arc right here. And then this one here, the angle on the outside, it's intercepting an arc, and the other arc it's intercepting is actually taking up the whole rest of the circle. Okay, but either way, there's a big arc and a small arc. Okay, there's a big one and a small one. Okay, so how you're going to do this here, you're going to take the big one, measure of CE. You're going to subtract the small one, measure BD. You're going to multiply that by 1/2, and that's going to equal the angle on the outside. Okay? Oh, and I had measure angle equals. Okay, so this one here, same thing. Blue. Big arc minus the small arc times 1/2 will equal that angle on the outside. And then this one here, big arc, BDC, minus the small arc, BC, times 1/2 equals the angle on the outside, angle A. Okay, so it's kind of like the first ones we did, except instead of adding, we're going to subtract. Okay, so angle KLM, this angle on the outside, we're going to do the big arc minus the small arc times 1/2 equals this angle on the outside. Okay, so 140 minus 66 is 74. 1/2 times 74 is 37. All right, this one BCD. That's that angle on the outside, BCD. So the angle equals 1/2 of the big arc, 67, minus the small arc, which is, we don't have it, do we? So how are we going to figure that out? Well, this is a diameter, so half a circle is 180. So if I do 180, let's subtract that 67 and subtract that 94 to see what's left. 180 minus that 67 and then minus that 94, you get 19. So this little tiny arc right there, 19. So that's the tiny arc. So 67 minus 19 is 48. And 1/2 times 48 is 24. And that's your answer. All right, one page left, page 20. Just a bunch of examples on this page. Let's do the first one here. The big arc, we don't know. Small arc, angle. So the angle equals 1/2 of the big arc minus the small arc. Okay. And so let's see here. Multiply both sides by 2, we get 80 minus 75. Add 75 to both sides, and we get 155. And that is arc SW. Okay. Next one, big arc, small arc 46, angle. Angle equals 1/2 big arc, don't know, small arc 46. Okay. Let's see here, 35, multiply both sides by 2, we get 70. I don't want to put the 1/2, I just got rid of the 1/2. 70, x minus 46, add 46 to both sides, and we get 116. And that's QU, that's what it's asking for. Next one, big arc, small arc, angle. Angle equals the big arc, or 1/2 big arc minus small arc. All right, 135 minus 33, 102, so 1/2 times 102. And 1/2 times 102 is 51. Here's number 15. Okay, next one. Big arc, small arc. We don't know the big arc. We do know the small arc, but we don't have the angle either. Now we can find the big arc without having to work this out because we have two parts of the circle, and the big arc is just the rest of it. So I'm going to do 360 minus that 88 and minus that 62, and when I do that, I end up with 210. So now I can work it out. Angle is my x. Angle equals 1/2 big arc minus the small arc. 210 minus 62 is 148. 1/2 times 148 is 74. 4 questions left. Number 17. I need EF, but I'm going to have to solve for the small arc. So the angle equals 1/2 of the big arc minus the small arc. Multiply both sides by 2, and I get 77 times 2 is 154. 191 minus x. And I'm going to subtract the 191 from both sides, and I get 154 minus 191 is negative 37 equals negative x. Multiply both sides by -1, and I get x equals 37. That's the arc. To find my angle that it's asking for, I need to do 360 minus that 191, and then minus that 37 I just found to get the rest of it, which will be 132. All right, next one here. MK is the small arc. We got the big arc. We need to find the small arc. We have the angle. The angle equals 1/2 of the big arc minus the small arc. Multiply both sides by 2, we get 112. Subtract 160 from both sides, and we get 48, negative 48. And multiply both sides by -1, x is 48. Okay, 2 questions remaining. Big arc, don't have the small arc or the angle. But the big arc and the small arc are the whole circle. So 360 minus 313 gives me 47 for the small arc. So now we can do it. The angle, 1/2 big arc minus the small arc. 313 minus 47 is 266. 1/2 times 266 is 133. And that is your angle, PQR. Final question. The big arc I don't have, but it is the rest of the circle. 360 minus 106 gives me this. It is 254. Right? Angle equals 1/2 big arc minus a small arc. Okay. And let's see here. 254 minus 106 is 148. 1/2 times 148 is 74. And there's pages 18, 19, and 20 notes. Ready to go.